Okay, so in this lecture, I want to talk about necessary and sufficient conditions. And these are actually really important. Um, you'll see these in science and math as definitions, but they're actually pretty important in law and sort of legal matters. When you give legal definitions for things, you know, lawyers and judges aren't philosophers, so they won't put it in these terms, but a lot of times they'll be offered as necessary or sufficient conditions. Um, you know, you might think of a contract. Once we get the concepts down, I think you'll see how this works. You might think of things you need to do to make sure the contract is satisfying or different ways of satisfying it. You can think of that in terms of necessary and sufficient conditions. That'll make a lot more sense, though, when we figure out what necessary and sufficient conditions are. So let me give you guys a few examples of necessary conditions. You must be at least 42 inches tall to ride Space Mountain. The president must be 35 years old. To pass the class, students are required to attend at least 3/4 of the class meetings. And finally, winning the lottery requires that you buy a ticket. Now think about what these are saying, right? If I say you must be at least 42 inches tall to ride Space Mountain, Space Mountain is a ride in Disney World, doesn't mean that everybody who's that tall, which I think is 3 feet 6 inches, could ride Space Mountain, right? If you don't buy a ticket to Disney World, if you're nowhere near Disney World, you can't ride Space Mountain, right? But we are saying we're not saying that everybody who's 42 inches tall can ride Space Mountain. We're saying that no one who can ride Space Mountain is less than this tall, right? President must be 35 years old. Not saying that every 35-year-old instantly becomes president of the US. We're just saying anyone who is president has to be this old. Pass the class, you have to attend 3/4 of the class meetings. Not saying that everyone who attends 3/4 of the class meetings is going to pass. There might be other things you have to do. What we are saying is if you don't attend that many class meetings, you definitely won't pass. Winning the lottery requires that you buy a ticket. Well, sadly, not everybody who buys a ticket wins, but no one who doesn't have a ticket can win, right? So, when we say X is a necessary condition for Y, what we're saying is you cannot have Y without X. We are saying if you don't have Y, you can't, or sorry, if you don't have X, you can't have Y. We're not saying that every time you have X, you also have Y. Plenty of people who are 35 aren't president after all, right? We are saying if you don't have X, you don't have Y. Not necessarily if you do have X, you do have Y. So think about it for a minute. If we're using our all, some, none language, how would you put this in the form of a categorical statement? There's two ways to do this. I think actually though the all way is the easiest, the least roundabout. X is a necessary condition for Y. All Y cases are X cases. We're saying not that every time you have X, you have Y, because that's not true. We're saying that whenever you have Y, you have to have X as well, because you can't have Y without X. You don't know that all people over 35 are president, but you do know that anyone legally elected president is going to be 35 or older. You must be 42 inches tall to ride Space Mountain. All people who can ride Space Mountain are at least 42 inches tall. The president must be at least 35 years old. All presidents are people who are at least 35. Now, there might be different ways to put these, but this is the basic idea, right? And they're going to have this same basic form. To pass the class, students are required to attend at least 3/4 of the class meetings. All students who passed are students who attended 3/4 of the class meetings. Winning the lottery requires that you buy a ticket. All people who win the lottery are people who have bought tickets. Now, this one might not be true. It might just be that you have to have a ticket. Maybe someone buys you a ticket as a present or whatever, you know. But the idea is, you cannot win the lottery unless you have a ticket. Sufficient conditions are a different thing. Any student using AI will write their papers will fail. Falling into lava will kill Mario. Being born in the US is one way to become a citizen. Now, with these, we're not saying, well, for a student to fail, they have to use AI. There are lots of ways to fail a class, right? If you sit down and write your own papers, but you just free associate whatever comes into your head and it has nothing to do with what the professors talked about in class, in most classes you will fail, right? Falling into lava will kill Mario. Well, if you've ever played the Mario Brothers games, that's one way for Mario to die. He falls into the lava. But there are plenty of other ways for Mario to die. These aren't necessary conditions because we're not saying, well, for Mario to die, he has to fall into lava. If he gets hit with one of those little turtles, he'll die. If he falls onto spikes, he will die. In some of the Mario games, if he runs out of time, he will die. Lots of ways for poor little Mario to, buy the farm, right? Being born in the US is one way to become a citizen. We're not saying that all people who are citizens are born in the US. There's lots of other ways to become a citizen. You can be born somewhere else and naturalized. You go through the whole citizenship process. You can have an American parent. If one of your parents is an American, can be born in Germany, or if we had a moon base, you could be born there and you would still be an American, right? We're not saying it's a necessary condition that you have to be born here to be a citizen. Lots of people who weren't are citizens. We're just saying that's one way to be a citizen or to become one. All right. So to put this kind of very abstractly, when we say X is a sufficient condition for Y, we mean whenever you have X, you also have Y. Anytime you have X, you're also going to get Y. Anytime you're born in the US, you're a citizen. Anytime poor little Mario falls into lava, you're going to get Y, which is Mario dying, right? Does not mean that you have to have X to have Y. Lots of other ways for Mario to die, lots of other ways to be a citizen, lots of other ways to fail most classes besides not just showing up, right? Just using AI. So these two we can put in the form of categorical statements. And these two, we would use the all, but we have to be careful with the order. Any student caught using AI to write their papers will fail. Well, we would rephrase that to all students caught using AI to write papers are students who fail the class. Falling into lava will kill Mario. All cases where Mario falls into lava are cases where Mario dies. Being born in the US is one way to become a citizen. All people born in the US are US citizens. So, necessary condition, can't have Y without X, but X doesn't necessarily get you Y. Sufficient condition, whenever you have X, you also get Y, but you might be able to have Y without X. That's the basic idea. Now, you don't see these a whole lot, but it's good to keep them in mind. Sometimes you will see things that are both necessary and sufficient conditions. These usually pop up in definitions, especially definitions in science and math. Here's some examples. Gold is an element with atomic number 79. That is the scientific definition of gold, or at least one of them, right? Water is a compound with the chemical formula H2O. An even number is any number divisible by 2 without remainder. Well, what are these saying, right? This is saying that anytime you have gold, you have an element with atomic number 79. But it's also saying if you have a big old lump of element with atomic number 79, you have gold. Being gold is a sufficient condition for being atomic number 79 element. Being atomic number 79 element, sufficient condition for being gold. They're also necessary conditions. Water is a compound. If you were putting this in ordinary English, you might say only gold is element with atomic number 79, and only atomic number 79 element is gold. Another sort of chemistry, sort of science definition, water is a compound with chemical formula H2O. All water is this stuff, and all of this stuff is water. And only water is this stuff, and only this stuff is water, right? An even number is any number divisible by 2 without remainder. Well, so how would we put this? Well, you actually have to translate this. There's other ways to do this when you are using other forms of logic, but with categorical logic, you need 2 all statements. All elements with atomic number 79 are gold, and all gold is an element with atomic number 79. Water is a compound with the chemical formula H2O. All water is an element with the chemical formula H2O. All compounds with the chemical formula H2O are water. An even number is any number divisible by 2 without remainder. All numbers divisible by 2 without remainder are even numbers. All even numbers are numbers divisible by 2 without remainder. So you're not going to see these a whole lot in ordinary life. You will see them offered as definitions in science and math, sometimes elsewhere too. When you get this very strict definition, a lot of times it's being offered in terms of sufficient and necessary conditions. When you see these, know that you have to use 2 all statements to capture the idea. All right, so hopefully the basic idea of sufficient and necessary conditions and conditions that are sufficient and necessary together makes sense to you guys. Like anything with logic, it just takes some practice. Once you have the basic idea, we will do a lot more practice with these.